Okay, so we're in section 122.3 and going to start the exercise. We'll start with number one. All right, I realize it's a difficult section. This might be a little archaic for some students, but nonetheless is an important thing that's still covered today in most algebra classes. So we're going to go to the whiteboard to do it. As I do that, I need to write it down, and I got to open it up on my computer now. And f of x, and I'm just speaking through it at this point, but I'll write it down. It's a function, and we're trying to count the roots to it, you know, with the nature of the root, so to speak. Whoops, it's plus minus 14x minus 144. You know, just to get a general idea before you proceed forward, you notice the cubic leading coefficient is positive, so it's going to look sort of like this over here. Right, sort of. I'm not saying exactly like that. And what do you know about the intercepts? Well, the x-axis could be here. That means there'd be one real, two complex. It might be over here, the x-axis. That means there's two repeated. There'll be three altogether, right? And you could do, you know, another case over here, do it like here, and then you see three roots. I know I didn't get a good job on that one. You know what I'm going to make it more exaggerated. So something, I'll make it really exaggerated, something like this over here. So one real, three reals, but two repeated, three reals. Over here, you could have two reals, I'm sorry, three reals, but two repeated. Over here, one real, two complex. You get the idea. Now, of course, they want me to do Descartes rule of signs. So I got to erase this over here, and we'll talk about that. All right? So let's write this down. Plus, I'm doing the coefficients, minus, minus. I got to determine the number of sign changes, and there's only one. So S is 1. And now S minus P, let me discuss what this is. S is the number of sign changes. P is the number of positive roots. This must be a non-negative, even integer. What does that mean? 0, 2, 4, yada, yada, yada. Well, what's S? S is 1. P must be 1. So I know there's one positive real root. I know that. All right? Now, what I'm going to do now is rotate the curve to take the negative roots to make them positive. To rotate the curve about the y-axis, I just evaluate the function f of minus x. What would that give you? Minus x cubed plus x squared plus 14x minus 144. Let's put the signs down. Minus, plus, plus, minus. What do you got to do now? You need to count the sign changes. All right? I know it's difficult, but let's see if we can do it. When you get over here, one here, and one here. So S equals 2. Let's keep going. So now S minus P, and remember S is 2, must be a non-negative even integer. So P could be 0, or the P could be 2. I know that's not conclusive, but that's what we have at this point, all right? So we know there's one positive root, it's a real number, and now there could be 0 or 2, all right? So I'm going to write down the possibilities. There's one positive real root. There could be two complex as well, all right? There could be one positive real root. That's always the case, by the way. And there could be two negative. That's the possibilities. I want to go to the picture, though. Why do you want to go to the picture? You know, I want to see what the real case is. By the way, we could do more analysis to figure out what the case is. For example, over here, we could definitely do more analysis to figure out which of these two cases. Is it this one or this one? And the analysis is not bad. You know, simple sign analysis, intermediate value theorem will help us out with that. all right? But what I do is just go back to the picture, and I want to emphasize that, which case is it, all right? So we put this down for you for a reason. This is figure 292. And what's the real answer over here? Again, I put two possibilities down, but one real. Let me write that down for you. There's one real. I see that right here, two complex. All right? We did put that down, by the way, but we put two different cases down. Again, we're trying to refine this a piece at a time. Thank you for paying attention. Oh, before I forget, my name is Ron Bannon, and my email address, in case you need to reach out to me, is Bannon, B as in boy, the @ symbol, NNON.US. Now, again, I want to point out what I did. I basically talked through the notes. That's all I'm doing. Now, certainly when I do that, it doesn't look the same, and that's true. My chicken scratch, my typeset work definitely looks different. All right? Thank you for paying attention.